In this video, we are going to evaluate the derivative of the exponential function a to the x. For the purposes of this exercise, we will assume that a is a positive number because it's possible that if we raise a negative number to a real number exponent, we get an imaginary number, and we don't want to deal with those right now. For example, if we were to raise negative 2 to the 1/2 power, that would be the same thing as the square root of negative 2, and that's going to be I times the square root of 2, and we're not going to deal with imaginary numbers right now. We'll also assume that a is not equal to 1 because 1 to any power is just going to be 1, and that would be a meaningless exercise. So what we want to do here is we want to find the derivative of a to the x, and we will start that by letting y equal a to the x. We're going to use some laws of logarithms here to incorporate e to the x. We've already found that the derivative of e to the x is e to the x, and that's something that we know how to do already. So we're going to try to use that property to evaluate this derivative. So what we'll do is we will take the natural log of both sides of this equation, and so what we get is the natural log of y equals the natural log of a to the x. And we know as a property of logs that this can be written here, this exponent can be multiplied out front, and this is equal to x times the natural log of a. So what we have now is the natural log of y equals x times the natural log of a. Getting y by itself now is fairly simple. This is a log with a base of e, so we can rewrite this now as y equals e to the x natural log of a. So now that we know that a to the x is equal to e to the x natural log of a, we can use the derivative of e to the x that we have previously learned. So the derivative of y with respect to x is going to be the derivative of this right here, e to the x times the natural log of a. Remember that the derivative of the exponential function with base e is e to the x natural log of a, but then we also have to multiply that by the derivative of the exponent x natural log of a. That's using the chain rule here. So we take the derivative of the mother function, e to the x natural log of a, times the derivative of the baby function. And let's go ahead and replace that right away with the derivative of the baby function. So the derivative of x times the natural log of a is simply the natural log of a. And the reason is a is a constant, and so the natural log of a is also a constant. This right here is just simply a number, and the derivative of x times a number is that number. Now, we do want to simplify this a little bit. Since we know that e to the x times the natural log of a is equal to a to the x, then we can rewrite this part right here, e to the x natural log of a, as a to the x, and then times the natural log of a. So the derivative of the exponential function a to the x is a to the x times the natural log of a. Similar to the derivative of the exponential function with e as the base, except that we have this right here, this natural log of a, which comes from using the chain rule. You may also notice here that if we use e as the base where a is, then the derivative of e to the x is going to be e to the x times the natural log of e, and the natural log of e is 1, so we would get the natural log of e. If we wanted to write this derivative as a chain rule formula, that formula would look like this. The derivative of a to the u, where u is a function of x, is a to the u times the natural log of a times the derivative of u with respect to x.